Hello students, welcome to my channel Maths with Pannu. Today we will discuss about some applications of derivatives. So let's start. Our today's topic is tangents and normals. So first of all, we should know about what is the tangent. When a curve touches a line and this is a point of contact. So this condition is called tangent. Okay, and when a line becomes perpendicular to this, then this condition is called normal. Okay, now our first question is that okay, what is the slope of tangent? Okay, what is the slope of tangent? So students, when we take a function, suppose we take y is equal to x square plus 5x minus 3. Okay, and when we take its first derivative, and the derivative of x square is equal to 2x and derivative of 5x is equal to 5, then dy by dx is called the slope of the tangent and we can denote it by the letter m. Okay, now what is the slope of normal? Slope of normal, that is minus 1 upon dy upon dx, and we write it as 1 upon minus 1 upon m. Means when we take m as negative and reciprocal, then it is called the slope of normal. Now our next topic is what is the equation of tangent. How we can find out the equation of tangent? So to find this equation at a particular point like x1 and y1, we will take this formula y minus y1 is equal to mx minus x1. Okay, to understand it, we take an example like like y is equal to we take it as x cube, only x cube. Okay, and at the point 1 1. Now first of all we write its derivative dy upon dx, and the derivative of x cube is equal to 3x square. This is called m. When we put x is equal to 1, because this point is of x1 and y1, and we find the slope, we put here 1 in place of x and we get 3 into 1 is equal to 1. This is our slope, and now we apply the formula and we write here equation of tangent at 1 1, that is y minus y1. Okay, what is y1? y1 is 1 here, and slope, what is the slope? That is 3 and x minus x1. Okay, I repeat, The equation of tangent is y minus y1 m x minus x1, and this point is of x1 and y1. We write it in the place of y1 and x1, and then we write our value of m, that is equal to 3, and we solve it algebraically, and we get y minus y1, 3 multiplied by x, 3 multiplied by 1, and by applying some algebraic operations, and we get it answers 3x minus y minus 2, and in the form of the straight line we get our answer. Okay, so then this is our equation of tangent. Now we move on equation of normal. From the same example we can change only, we put minus 1 upon m instead of m. Okay, now we write here y minus y1 minus 1 upon m x minus x1. For what? For the equation of normal. Okay, and we write here y minus 1 minus 1 upon 3 x minus 1, and then we find y minus 1 after multiplying this as a cross multiplication, and you get your answer minus x plus 1, and you get minus x, and you take it on the left hand side, x plus 3y minus 3 minus 1, and we get x plus 3y minus 4 is equal to 0, and x plus 3y is equal to 4. This is the equation of a normal. Now we have some other conditions of tangent and normals, like if we have two lines, for example y is equal to x square plus 2x plus 7, and y is equal to 3x minus 11. Okay, and if he says these lines are parallel, the lines are parallel. For the condition of parallel, we write here m1 is equal to m2. This is the main condition of parallel lines. When two curves are parallel to each other, then we apply m1 is equal to m2. Now what is m1 and m2? m1 is the derivative of this equation, and m2 is the slope of the straight line. So for getting m1, we find the derivative of y, and we write here dy upon dx is equal to 2x plus 2, and we write here in the place of you can also find the derivative of y also, then dy by dx you get 3 also, and instead of this you apply an formula that slope of an straight line like ax plus by plus c is equal to 0, and you can apply the formula minus a upon b. So in this way, when you apply the formula, then you write it in this form 3x minus y minus 11, and the coefficient of x is 3, that is a, and we write here 3, and the coefficient of y is minus 1, and you get the slope 3. In this way you can also get the slope. And in the other way, if you find out the derivative of this equation, then dy by dx, and you get your direct answer, that is equal to 3. Okay, you can choose any way, both of them, though you get your two slopes. m1 is equal to 2x plus 2, and m2 is equal to 3. And for the parallel lines, you write here m1 is equal to m2, and m1 and m2 you put the values of both, then you get 2x plus 2 in this way. 2x plus 2 is equal to 3. Then you write here 2x is equal to 3 minus 2, and you get 2x is equal to 1 and x is equal to 1 upon 2. Okay, then you get your point. And if we says find the coordinates, you find the points, then for this you put this value of x in your equation y. So you can put it in the place of y in your curve, whatever. So then you get your answer. What is the equation? We have an equation x square plus 2x plus 7. Okay, so sorry, we write here 7 and you put 1 by 2 instead of x in the place of x, and you get your answer. So we get it 1 by 4, cancelling 2 with 2, and you get 1 plus 7, and after solving it you get your answer in this way. Okay, so your answer is 1 by 2 and 13 by 4. In this way you can find the point of intersection, because these lines are parallel, so it does not necessary that he sees you to find the points. Okay, but when we have the condition that lines are intersecting each other and the condition is of perpendicular, okay, when the lines are perpendicular to each other, means we apply the condition m1 m2 is equal to minus 1. Suppose we take the same lines and we take the same example, 2x plus 7 and y is equal to 3x minus 11. Okay, now if these lines are perpendicular to each other, then you take the first derivative of this and you can apply, you can write here 2x plus 2, and for m2 you can take the derivative of it 3. And if these lines are perpendicular, then we apply the conditions m1 m2 is equal to minus 1, and for that we write here 3 is equal to minus 1. For this you multiplied it, you get 6x plus 6 minus 1, and 6x is equal to minus 1 minus 6, and you get your answer minus 7 upon 6. And in this question he says you to find the point of intersection. In that case you put the value of x in your original function, because when the lines are parallel, so there is no common point between these two lines. Okay, and when lines are perpendicular to each other, then mostly they have their common points. Okay, when curves are perpendicular, the same condition is applied for this. But if he says that to find the coordinates, then you put the value of x in your function as I had told you firstly, and you write here minus 7 upon 6 to the square, 2 minus 7 upon 6, and solving it you get your answer. Okay, and when he says lines are parallel, I repeat my point, we need not find to the point of intersection. So this step is not necessarily for this question. Okay, and your question is absolutely finished at this point, and we need not find out the points. Okay, we need to find out the points when our lines are perpendicular. The next condition of the tangent and normal question is that when he gives you the condition when your tangent when the tangent is parallel to x-axis. Okay, parallel to x-axis, then you put the derivative or the function is equal to 0. And when he says the tangent is parallel to y-axis, then you put dx upon dy is equal to 0. Okay, and when you put dy by dx is equal to 0, then you can find the value of x, and by putting the value of x in your original function you get the 2 points also. The same process is applying here, and when you put dx by dy is equal to 0, then you find the value of x or y, and you put the value in the original function, you get also the another points. So in this question you can get the coordinates of your equation, and in this equation also. So students, this is there is some questions of some applications of derivatives, and we will discuss its next types in my next videos. Thank you.